All right, let's talk about a piece of technology that's quietly changing everything about AI and search. It's called a vector database, and it's the reason computers are finally starting to get what we mean, not just what we type.
But let's start with a really basic question. You and I, we just know that a photo of a golden retriever is similar to a photo of a Labrador, right? But how in the world does a computer, a machine that only thinks in ones and zeros, how does it grasp that idea of similarity? Well, that's the big puzzle we're going to solve today.
So here's our game plan. We'll start with why old-school search just doesn't cut it anymore. Then, we'll get into the secret sauce, vector embeddings. We'll look at the special databases built just for them, follow the data from start to finish, and wrap up by seeing where this tech is already making a huge impact.
Okay, first up, searching beyond keywords. To really appreciate why vector databases are such a big deal, we got to look at what we were working with before.
Think about a normal database like a giant, perfectly organized spreadsheet. If you hit Control F and search for Alice or Invoice 101, bam, it finds the exact match instantly. It's absolutely perfect for superstructured data when you know precisely what you're looking for.
But what if your search is a little more fuzzy? How do you tell a computer to find a song that feels like a lazy Sunday morning? Or a shirt with a similar style to one you saw? Yeah, a simple keyword search is totally lost here. It just doesn't get context. It doesn't get meaning.
So, how do we fix that? Well, this is where the magic really starts. The secret is something called a vector embedding. You can think of it like a universal translator that turns everything, words, pictures, sounds, into a language that computers can actually understand on a deeper level.
So what is an embedding? At its heart, it's just a long list of numbers, a vector. But here's the trick. These numbers are generated by a special AI model. And this model is trained to capture the meaning or essence of something, so that similar concepts get assigned similar lists of numbers.
Here's what that looks like in practice. You take something messy and human, like a sentence, you feed it into one of these embedding models, and what you get on the other side is that clean list of numbers. That vector now holds the mathematical DNA of that sentence's meaning.
And this is the real breakthrough. Once everything is represented by numbers, we can use simple math to compare them. We can literally measure the distance between two vectors. If the distance is small, it means the original things, whether they were images or sentences, are conceptually very, very similar. It's genius.
Okay, so now we have this amazing new way to represent data. But these vectors need a special place to live. You can't just cram them into a regular old database and expect it to work. We need a whole new type of home for them.
And that, my friends, is a vector database. It's a database that has been built from the ground up for one job and one job only: to store, index, and search through millions or even billions of these vector embeddings at lightning speed. It's all about finding the closest matches, not the exact ones.
So let's just put it side by side to make it crystal clear. Traditional databases, they're for finding exact words or numbers in neat, organized rows and columns. Vector databases, they're for finding similar concepts in all that messy, unstructured stuff like text, images, and audio. Totally different tools for totally different problems.
And believe me, this isn't just a theory anymore. There's a whole ecosystem of these databases exploding right now. You've got big players like Pinecone that can scale to massive sizes, Weaviate for more flexible hybrid searches, and things like ChromaDB that are super easy for developers to get started with. The whole space is moving incredibly fast.
Okay, so let's put all the pieces together. Let's trace the entire journey. How do we go from, say, a random photo on your camera roll all the way to a useful, meaningful search result?
This slide gives you that bird's eye view. You start with your raw data on the left. Could be anything. It gets passed to an embedding service, which is that smart AI model we talked about. That service spits out the vector data, which then gets stored and indexed inside the vector database, all ready for you to search. And if we zoom in, it looks like this. Step 1, you feed it the data. Step 2, a model gets to work, pulling out all the key features, like objects in a photo or topics in an article. Step 3, it encodes all those features into that list of numbers, the vector. And finally, step 4, that vector is filed away in the database, ready to be found.
And what's so wild is that this same basic recipe works for just about anything. Images, text, audio clips, it doesn't matter. And that's what unlocks this huge range of new possibilities, from identifying what's in a picture to figuring out if a customer review is happy or angry.
Okay, let's make this real. Where is this technology actually showing up?
I think you'll be surprised at how many tools you probably use every day are already powered by this stuff.
Ever used a visual search on a shopping website where you upload a picture to find similar items? That's vector search. Or what about chatbots and AI assistants that can find genuinely helpful answers from documents instead of just stuff with the right keywords? That's vector search too. It can even search for concepts across different languages or spot fraud by finding behavior that is mathematically far away from normal.
And the bottom line here is just a massive leap in how accurate and relevant search results can be. Because you're searching by meaning, you get what you want, not just what you typed. It's a game changer compared to simple keyword matching.
So look, if you walk away with just one idea today, make it this one. The crucial point is that vector databases are what finally allow computers to search by meaning and by context. We've moved on from just matching words to actually matching ideas.
And that kind of leaves us with a really exciting question to think about, doesn't it? If computers are getting this good at understanding the intent behind what we ask, what completely new, incredible things are we going to ask them to do next?